In 3.1, our objective is to be able to identify relationships between lines. Also, to identify angles formed by transversals. Let's begin by talking about line relationships. You've heard of these before. I'm going to review them with you today. Parallel lines are lines that do not intersect. They do not intersect. However, they are in the same plane. Skew lines also are lines that do not intersect, but they are in different planes. That's hard to imagine when you're looking at a two-dimensional paper. So we're going to look at a three-dimensional drawing on two-dimensional paper for you to understand that. So both of these types of lines do not intersect. If we take a look at this drawing right here, think of this as a three-dimensional box or perhaps a cube. Think of it as a box. Parallel lines, such as a line that is parallel to line AB. So here's the side of the edge of the box that's AB. If I extend that like this, I'm looking for a line that does not intersect but is in the same plane. That would be like line CD. That is a line that is parallel to AB. Also, GH is a line that is parallel. So both of those are good examples of parallel lines. There are many other lines that are parallel to AB. Those are just a couple of examples. Now, skew, on the other hand, the lines that are skewed to AB, those are going to be ones that don't intersect but in a different plane. What does that mean, in a different plane? Well, the plane of the side of the box includes line AB. But line EH is a line that's never going to touch line AB because it's at the bottom of the box. However, it's not in the plane that AB is. It's in a different plane. So skew is EH. Now, another way to think of being in a different plane is going in a different direction. Let's make that note. So skew lines we can think of as go in different directions, but remember they still cannot intersect, whereas parallel lines that also cannot intersect go in the same direction. So two-dimensionally, we would look at a drawing of parallel lines like this, and perhaps a drawing of skew lines like this. But we really have to think three-dimensionally for skew. So again, to our picture, skew to line AB could be line EH. It could be line FC. This is the edge of the box that's in the back in a different plane. So I could say, or line FC. Let's talk about parallel planes and perpendicular lines. Now, on the lines, parallel lines, skew lines, perpendicular lines, staying on that track of lines, these are lines that intersect at a right angle. There's our abbreviation for angle, that symbol, intersect at a right angle. Remember, right angle, 90 degrees. So a picture of that would look like, here's one line, here's a second line. And remember the symbol we use to show it's perpendicular or 90 degrees. Speaking of symbols, when we have to write shortcuts, parallel, the symbol is like the double L in parallel, or like two parallel lines, and a symbol we use for perpendicular is like two perpendicular lines, or like an upside down T. Let's go to our drawing of the box and identify which lines are perpendicular. So perpendicular to line AB, so intersecting it at a right angle. This line that is the front edge of the box makes a right angle with line AB. So that would be line AD. Or, because we're imagining this is a box, like a cube with right angles, perhaps line BC is another line perpendicular to AB. Oops, did I say C? Sorry, BG, BG, BG. Now we said parallel lines are lines that do not intersect. Using the word parallel for planes, these will be planes that do not intersect. So what does that look like? Well, remember we draw a plane kind of like it's a rectangle or parallelogram, and another plane we just have to imagine going in the same direction. That's kind of hard to draw, so let's take a look at the box. What is a plane that's parallel to plane ABC? Well, where's plane ABC? Point A, point B, point C are points in the top of the box. So ABC is the top of the box. Plane ABC, top of the box. Parallel, not intersecting, going in the same direction is a good way to think of it. Let's think of parallel as go in the same direction. Go in the same direction. So what's parallel to that plane ABC? This bottom of the box plane. This plane at the bottom of the box. And remember, we can name a plane any three letters, such as E, F, G. Plane E, F, G is parallel to plane ABC. This leads us to two useful postulates that we'll be using when we prove other theorems. The parallel postulate. Given a line, so we'll be given a line. So in a picture, I'm going to draw a line and a point not on the line. So anywhere not on the line is fine. There must be exactly one line through that point that will be parallel to the given line. What does that mean? I can draw lots of lines through this point. I can draw a line like this, or a line like this, or a line like this, but there is only one possible line that I can draw that will be going in the same direction, never intersecting this other line. Seems pretty straightforward, which is why it's a postulate. Postulates are accepted without proof. Perpendicular postulate, very similar. We're given a line and a point not on the line. But this time we say there is exactly one line through that point that will be perpendicular. Unlike this one was parallel, it would be perpendicular to the given line. So one exact way that I can draw a line that is perpendicular.